The ITR Center for Advanced Technologies is working on new materials and technologies implemented in small and medium-sized enterprises in the electronics sector. These are, among others, environmentally friendly materials and technologies for soldering, electronic components for printed circuits with high packing density, nanomaterials used in soldering pastes, hydrogen sensors and pastes and inks used in the production process of printed electronics. The TELE and Radio Research Institute is also developing modern technologies of electronic microassembly, lead-free, and testing the quality of materials, engineering processes, and electronic products. Our experienced specialists and state-of-the-art research equipment allows in-depth analysis of those parameters of components used in the assembly of electronic products, which affect the quality of the finished product. Our research facilities allow the testing of the properties of moisturizing soldering alloys, the solderability of electronic components and printed circuit boards, the thickness of soldering coats on printed circuit boards, the quality of soldering pastes and fluxes, or compliance with the RoHS directive. The engineers from the TELE and Radio Research Institute are examining and optimizing parameters of operations used in the assembly process of electronic devices. Among them are paste printing processes and reflow soldering profiles. In addition, the Institute performs quality and reliability tests on the execution of electronic assemblies and individual soldered joints. Both external soldered joints can be assessed using microscopes, as well as the internal structuring of joints using a radiographic method. Also, metallographic microsections of printed circuits, assemblies and soldered joints are carried out, which can be used to detect all defects hidden from visual inspection. Scientists of the TELE and Radio Research Institute also have at their disposal a modern electron microscope. Therefore, the thickness of the intermetallic compound in soldered joints, which directly affects the reliability of electronic equipment, can be measured. Our institute is working with a number of companies and research organizations, both European and global, including Shanghai University. Collaboration between the institute and Shanghai University started during implementation of an international project and was related to environmentally friendly technologies in the electronics sector. The results of the collaboration were a series of European and domestic projects. An innovative lead-free soldering technology was implemented, eliminating lead from electronic products. The TELE and Radio Research Institute Center for Advanced Technologies is continuously meeting new challenges, staying in the mainstream of global research. Particularly interesting are electronic device miniaturization and microassembly projects. Those technologies allow incorporation of component parts to the inside of a printed circuit, which both reduces the size of devices and improves their functionality. Among many achievements of the Institute is a next-generation lead-free soldering paste, utilizing the developments of nanotechnology. This reduces the temperature of reflow soldering while improving the strength and reliability of joints. We have only just started to work with printed electronics. Our research is focused on jet printing and investigation of jet printing technology and materials. Since this area is only starting to be developed worldwide, we have also joined the Global Research Program. This technology combines organic and inorganic materials with various printing technologies. As a result, new areas of application are created for electronics. The Institute examines material and techniques of silkscreen printing and jet printing, used in production process of, among others, radio identification circuits, RFID, which improve the logistics of goods. RFID circuits also change the way we shop. Instead of queuing, you can simply walk with your shopping cart through a special gate, which immediately sums up the value of the goods in your cart without removing them. Work is also in progress on printable transistors and solar cells. Utilization of nanotechnology in those areas is possible thanks to the current research by the TELE and Radio Research Institute. Nanomaterials are materials with nanometric dimensions, 1/1000th part of a meter in diameter. Properties of nanomaterials differ from those of bulk materials. One of the most characteristic features of nanomaterials is their high surface-to-volume ratio, which results in improvement of some properties, e.g. mechanical or electrical. Nanoparticles in nanomaterials can take all shapes. Balls, for example the particle of fullerene, diameter 0.7 nanometers, is built of 60 atoms of carbon. Tubes, for example carbon nanotubes, with a length more than 1 micrometer. Or other shapes such as flakes or onions. An innovative method developed in the Institute allows for the production of carbon nanomaterials modified with nanoparticles of metals such as nickel or palladium. Multi-wall carbon nanotubes can be produced using nickel nanoparticles by catalytic process of xylene pyrolysis. The length of the nanotubes produced by this method depends on the process duration, and the diameter depends on the size of the nickel nanoparticles. Such carbon nanotubes are used in the production process of nanocomposites for electronic products. Thin layers, below 400 nanometers, of short carbon nanotubes with low density of distribution on the surface can be produced using an organic metal compound of nickel and fullerene C60, and then introducing xylene in the pyrolysis process. To that end, a two-stage method, PVD-CVD, is used. Such thin layers of carbon nanotubes feature a high electric field amplification coefficient, so they can be used as field emitters. The Institute has also commenced research work on the manufacturing of a prototype of a vacuum lamp with a removable cathode based on carbon nanotubes. This project is financed under the EU program ERANET. At the same time, other research is in progress on the production of nanoporous carbon-palladium layers for application in hydrogen sensors or hydrogen storage compounds. This research is financed from the funds of the European Regional Development Fund under the operational program Innovative Economy 2007-2013.